Going on, everyone? I'm going to start in just a second with some Arduino. Post a link in the chat where you guys can sign up. Go from there. Hello, what's going on, everyone? Let's get this going. I'm Zane. I'm going to be teaching you guys about Arduino today. Here, let me go ahead and post our event link here. And make a little announcement too. How's everyone's night going? My internet, funnily enough, went out like 5 minutes before I was set to start, so I almost had a heart attack. But thankfully, everything worked out in the end. Got back online. Ended up stressing over nothing, but here we are. Hello, people doing good? Perfect. Excited about Arduino. Yes, same here. Arduino is my favorite. Circuit student. What better name for learning about Arduino? Hello, Jeff. We got Wei here too. Awesome. Okay, so let me just go ahead and pop this in and we'll get started. So we're essentially just going to be going over the basics of Arduino, getting started with it. I'm curious here if anyone has any past experience with microcontrollers, or maybe if you've tinkered around with Arduino yourself. I'm honestly relatively new to it. I've been doing it for the past, I want to say maybe 6 months or so. I've had some fun with it. And over time, I've learned some pretty nice tips and tricks. It's given me a bit of a basis in circuit theory and just all sorts of concepts with electronics and electricity. It's really interesting. So register link, a bit of a watch live for all our Discord friends here who want to join us. No experience with Arduino. It's not too bad to jump into it. In fact, so Arduino free to install. So I'm going to cover the entirety of, I guess how you could say, how you could get involved with Arduino. So Arduino is really this little hardware circuit kit. I'll kind of show you in a second. But funnily enough, or I should say amazingly enough, there actually is an online simulation of the Arduino that we can all follow along with. There's this great website called Tinkercad that you can sign up and make an account on that allows you to go in and simulate the Arduino hardware. So we can learn how to make our own basic circuits and the like. Circuit student, you've played with your own Raspberry Pis and Arduinos. Very fun. Yeah, I didn't know the difference between the two until I started looking into it, until I started looking into microcontrollers and the like. Arduino seems to be much more just base level circuitry and the like, whereas Raspberry Pis is actually like software, operating system. I haven't done too much with Raspberry Pis yet. I should say I haven't done anything at all with them as of yet, but I'm excited to move on to those once I build some nice projects with the Arduinos. In terms of Arduino being free to install, just to kind of round out the answer to that question, The only software component to it really is there's a IDE that you can use, the official Arduino coding environment. But other than that, the Arduino is actually just a microcontroller, a piece of hardware that comes with typically like a breadboard and wires and all sorts of electrical components. But on Tinkercad, as I'm going to show you, we can actually do a software emulation. So normally, in fact, let me just go ahead and share my screen and show you guys what this is all about. So you kind of get a feel for exactly what I'm talking about. Like there's hardware and, blah, 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 what exactly that means. So if I just share my screen here. I'll just share my entire screen, get this going. So on Tinkercad here, I'm in I guess I can show you how it works. So I made my Tinkercad account. I've gone on and I'm on my main page here, everything. You can go to this Tinker portion. I think this is more so for the tutorials, but on the page that I was before, like your main home page, you have the designs that you've either can go on to make or that you yourself will create. So now on the home page, I can scroll down to circuits. Looks like I already made. Might have a limit. I'm not sure. Or no, you can just go up to the upper right-hand corner here, and I can say I want to make 8 circuits. Now the nice thing about Tinkercad is that it does have tutorials and the like. Like if I go here and as I showed a little bit earlier, go to the circuits here, it has all sorts of pre-rendered like little sandbox areas that actually have tutorials directly attached to them. So if I go look at more of these tutorials and I go down to where, I mean, this is a bunch of general electrical stuff that does, some of them do utilize Arduinos, but there's also Arduino specific tutorials with different projects and the like. You can see I've done a few of these myself that you can go through, and on the right hand side it'll go through the basics, and I'll already have an Arduino and everything set up for you. I think I'll forego the official tutorials here because they're here for anyone to just check out and run through. What I want to do instead is kind of just show you guys how to set this up yourself if you want to do your own Arduino projects, and also, teach you some basics of how this all works. So here in Tinkercad, on the right-hand side, we have different components that we can go ahead and utilize. I just booted up an Arduino, hence given the topic of tonight seemed topical. So boot up an Arduino. There's a couple things we have to get on the screen before things start making sense. Here we have a breadboard, which is where we're going to connect our different electrical components. This is all going to make sense in a second, I promise. Just need to do a bit of laying the foundation of the groundwork here. But here's our Arduino. Arduino is our start of the show. It's what we're going to utilize to ultimately make circuits, as we'll see in a second. So we're basically just going to be running wires from the Arduino to this thing called the breadboard here. The breadboard is where we're going to have our sea of components that we're going to, bring to life with our magical power of electricity, as we'll see. But I'll explain how all that works in detail once we actually get down and dirty with stuff. But let me put together a basic circuit so you all can see what exactly this should look like. Then we'll start talking a little bit about the theory. So I'm actually, as I said, relatively new to Arduino. I was doing web development for the longest time until I realized that I just don't really care about websites. They don't excite me. Pretty lucrative field, it seems like, but I like the thinking and the abstraction, the problem solving with it, but I don't know, interacting with the real world is just a lot more interesting to me, I realized. So I ended up falling in love with the Arduino after giving it a shot. But anywho, let's do some basic stuff with circuits, with Arduino, with all this amazing stuff we see on the screen. So what exactly is going on? Here we have our Arduino. Here I have a power source on the Arduino. You see I'm using this red cable to ultimately provide power to this band here. See how when I hover over this, there's like this green line of circles that pops up. This is because this electric current that's going to be generated is going to run all along this vertical strip here. Why? Because this vertical strip is entirely metal. It's an isolated metal strip right here. So what that means, what we can do with that, is we can go on to, where do we want to place this? I can essentially redirect the electricity to where we have a power source that's sending current through here onto this vertical strip. That's then going to ride along this red cable here to this horizontal strip. So this plus and minus, they're vertical metal strips. This A through E here, these are just horizontal metal strips that you can allow the current to travel through. So the whole name of the game is to have current travel through this pathway that we outlined for it, all the way back to the Arduino, specifically to the Arduino's ground. So we'll talk a little bit more about this theory and all once we have the basic foundation in place. But you're going to see, I have power here, goes through this first leg of the LED. And so naturally the current is eventually going to pass through this LED back to the Arduino. So I'm using red wires here to denote that that this is all stemming from the power source. Now I'm using black wires here to signify that I'm ultimately trying to go to the ground. This is like familiar color schemes, on like your car batteries and the like. So actually, let me put this in a more intuitive spot. So we can go like, say, right here. So when I connect this, we should ultimately have, and I run the simulation up here, we have lights. Just checking the chat and the like. A little bit annoying with the full screen screen share, but it's the best solution I found for things with this overall setup. But look at that, we've made light. Isn't it beautiful? What exactly is going on though? That's the main question. There's quite a bit of theory that we can delve into, just explaining all of what's going on here. It's really not too bad once we jump into it. But overall, you've heard me throw some terms out as I've been talking, as I've made this circuit here. And I actually want to explain what's going on in a little bit more detail. So essentially what we've just done is we've created a circuit. So a circuit is a closed loop of wires where we have a power source and we have a load, which is something to do with the energy that we're generating that's ultimately useful. Okay, so let's see what's going on. So we have our power source, which is, seems like in this setup, it's being provided by the computer. The Arduino itself, you have to hook it up to something to get power. So it looks like it's, in the software emulation at least, it's, yeah, you can see there's that little thunderbolt actually. So in this hypothetical or this simulated situation, the Arduino is hypothetically getting power from like a computer. There's also like a wall plug that it has here on the left-hand side that you could use for a real-world Arduino. You have to provide power in some way. And, oh, I think what just happened? Oh, I think when the simulation ends, okay, there's a little animation. I actually didn't realize that the first time. That's funny. So this start simulation button, right now it's unplugged, so there's no power. Start the simulation, power starts, and so now the current flows and all that's going through. So anyways, we have our power source. We need a closed loop of wires. Okay, so what exactly does that mean? So within a circuit, you need a point of highest energy, or at least a point of higher potential energy, and a point of least potential energy. So you can see here on the Arduino, we have this initial red wire hooked up to this 5V, 5 volts. This is our point of higher potential energy. Here we have this ultimate black wire being connected to the ground. This is the point of least potential energy in our overall circuit. You have to have this overall loop of higher potential energy, the circuit traveling through to the lower potential energy. There has to be this ability to cycle. Only with that do you ultimately have a circuit here. If I break it off at any one of these points, like if I break it off right here so that we don't go to ground in the end, you're going to see that the light completely cuts off. If I start the simulation again, there's no light. Even though this is hooked up to the higher potential energy, the 5 volts, it does seem like it should reach the LED, but nothing happens because we don't have that closed circuit. We don't have that closed loop. So I add this back, everything works as normal. Okay, so we have a power source, we have a closed loop, and we're doing something useful, right? I guess you don't necessarily have to, I guess useful is a bit subjective in certain circumstances, but we ultimately have our little circuit. That's, I guess, the main point for us is to light up this LED. So now a bit too with Arduino. This is actually something I haven't looked into too much myself, but with these circuits that we're building, they're known as direct current in terms of current flow. That means that the electricity is only going to flow in one direction. So as far as I know, it should just flow from this high to low. I think it's technically the other way around, but the math kind of works out the same, whether you do it from one direction or the next. It's ultimately just like one net direction. But the alternative to that is alternating current, AC, which I think like your wall outlets and the like use. But anyways, just know that your electricity is going to be following that one route. So just want to check the chat and the like for yes, so there is something about the LED that I haven't mentioned yet. We're actually supplying a little too much, I think you'd say too much voltage to it. Too much. That's why it's kind of freaking out right now. In fact, yeah, there's that little thing of text there. We're going to resolve that in just a second. But you can see the ultimate workings of the circuit here. Right, so now we have a little bit of an understanding of what we need. A power source, of course. We can also see that we need this closed structure, this closed loop. So just to trace this through one more time, the volt is going through here. From the power source, we get to this vertical strip here. The current rides along from this wire to this wire onto this horizontal strip. The current goes through the LED, out the other leg, to then go on to this adjacent horizontal strip, which then brings us to this vertical strip here, from where we then hop on this wire and go to ground. So we do make that successful loop around from higher potential energy to lower potential energy, or point of least potential energy. And it's pretty clear like how it does that. So that's kind of the big tip that I have at first when we're doing these, is just being able to realize like how the current is flowing. You can kind of trace it almost like one of those little maze puzzles that you'd have in elementary school, part of those like word, I don't know, those little worksheets they give you to keep you busy. Definitely helps to be able to visually trace like what's going on. Okay, so that's the basic of a circuit. So there's a few other things that I'll kind of throw out here in terms of concepts and the like. I do want to get to Ohm's law. Maybe we can cover a little bit about that. But, well, I guess a few other things about circuits as well. We saw that we have to have our complete path. Circuits components are going to use up all electrical energy as well. Each component is going to ultimately convert some of the energy in our current to some of the electrical energy within our circuit into other forms of energy. So we can see here that this LED is converting the electrical energy into light energy, or I guess you could just say into light. Current will also seek the path of least resistance to ground. So one thing that you definitely do not want to do is, in fact, I've never even tried out in the simulation. I wonder what it would do. Can we even do that? Let me see. If we can connect from voltage to ground. I wonder what it would say, if it would scream at us or what. Anyways, I put a little wire here. We'll make it red so you guys can see. This should cause a short circuit. Unless, okay, I guess nothing too bad happens. But normally, if you connect power straight to ground, you normally have a short circuit, which can cause some bad issues, namely fires and explosions and sparks and all that. I don't know if there's enough like electrical power to cause that here, but don't take my word for it. Maybe they just didn't want to animate fires and explosions and the like. But anywho, just some principles that we're going to keep in mind as we go on to build our circuits. So we have a good foundation in place there. What I want to do next is build some of the Arduino beginner projects. Explode too much current. Your light isn't turning on. We're going to tackle some circuits together. And we'll talk about, you'll be able to see like what exactly it is that we're doing together. And hopefully you can mimic that exactly. Yeah. I wish there was a way for you to like post a screen cap or something in the chat. That way we could tackle this together. But here, let me get the Arduino book booted up. We'll go through some projects together, just kind of talking about what's going on in each circuit. So again, those Tinkercad tutorials are actually pretty helpful. It's actually, I think they're just 1-1 with the Arduino projects book. So this is the book that you get as you when you buy the Arduino. And it gives you a nice mix of theory and like all sorts of stuff for you to know. But we're going to just kind of dive right into what's going on here. So, actually, there is an important thing about the LED that might give an answer to your issue. So, let's go ahead and set up this LED again. So the thing about LEDs, there's actually this handy button here where you can like flip components. You can like put them into a mirror image. There's something really important about the LED to know. An LED is a polarized component, which means that it only allows electricity to flow through in one direction. So the LED has these two legs. There's the anode leg. You can see when we hover over them, we get our names. The anode leg, which has to connect to power. And the anode leg is like a longer leg. You can't really see it on here, but if you were to have an actual real-world LED, this leg would be like being extended here. And well, that's kind of annoying. Anyways, this leg here that's bent is a little bit longer. This anode, this longer leg, is a little bit longer than the other leg, the cathode. So this longer bent leg needs to be connected to power specifically. So I actually flipped mine so that I could get this nice little setup here. So you can see that the anode is specifically connected to the power, and the cathode has to specifically be connected to ground ultimately. And so that's what we have. So when voltage is applied to the anode of the LED, right, when we get this connection to the power here, when voltage is applied to the anode and the cathode is connected to the ground, that's when we get our light. So go ahead and give that a shot. Oh, there we go. Perfect. Worked when you flipped it. Amazing. Yeah, I know. Just one of those little details that you just got to know. We got that in place. Yeah, so I know that LEDs are a polarized component. The capacitors that are used on the Arduino 2 are polarized components, as far as I know. At least if you flip a capacitor around with the wrong ends connected to power and grounds, it can actually explode. So yeah, you definitely want to make sure that you're hooking those up right, to say the least. Okay, so actually what we're doing right now is not too far off from the first little example circuit that they give. So some of the wire placement is different, but we have the same overall setup, right? We have this LED connected within the overall circuit. But there is one thing that we've left out that's pretty crucial. So right now there's too much energy, there's too much current going to the LED currently. You've noticed that when I start the simulation, it's like really, really bright, and it gives us a little warning message that the current is too high of a level. If you send in too much electrical energy to a component that can't handle it, then it can burn out. So here, this LED in the real world, it would get really, really bright for a couple seconds, and then it would just die, and you just botch the component. So we don't want that. So what do? How do we limit the amount of electrical energy that we're supplying to it so that we don't fry our little unit here? We can use something called a resistor. So what a resistor does is that it takes some of the electrical energy, or I don't want to speak incorrectly here. What should I say? Basically, there's not going to be as strong of a current running through the LED if we hook a resistor up to it. So they usually recommend a 200 ohm resistor. We didn't really talk about the crucial what would I call it? The three crucial aspects of if you know Ohm's law, like voltage equals current times resistance. We haven't talked about voltage, current, resistance just yet. I don't think it's too relevant as of right now. We can touch a little bit on it later. But basically, by putting this resistor in, it's going to weaken the amount of electrical energy heading to the LED. And you can see that it's connecting us from the cathode to ground, so the circuit is still going to work out overall. So if I run this now, the LED should not be too bright as to burn out. It should be a perfect brightness. There we go. So look at that. So no like big obnoxious flash, no warning. We're supplying a viable amount of electrical energy to it. So the way that it does it is it actually converts some of that electrical energy to heat. So I don't know if the resistor really gets like hot to the touch or the like, but essentially it's just how would you even articulate it? I don't know. Instead of having a bunch of electrical energy, you diminish the overall electrical energy by converting some of it to heat energy. We don't really care about the heat. We care about decreasing that electrical energy so that the LED doesn't, fry. So there we go. That's our first successful little circuit. We haven't burned anything out. We haven't caused any explosions. So pretty good accomplishment. And here's something that I don't quite understand just yet, is that it doesn't matter if you put the resistor like before or after. You can actually set it up exactly like this as well. To where we have like this wire to ground, but we have the resistor before. Always found that curious. I haven't learned exactly why this is the case, that it works no matter what. Okay, that's weird. Hold on. Oh, because this isn't connected to power. Again, you have to really pay attention. So now if I do this, it should work. There we go. Well, I've always found that curious. I haven't learned why it still works despite that. But anywho, so that's our first little circuit done. Anything for me to mention at the moment? Nothing yet. I think this is a good... I think we basically give a full explanation on everything that's going on in this first little exercise, at least. This book is really nice. They have, again, just a bunch of instructions, tutorials, and explanations on stuff, and then even little schematics. But okay, so resistor switch. Yeah, we're going to be incorporating a switch soon as well. So basically, yeah, just one step up from the circuit that we currently have. So let's see what's going on here. I want to check the chat here. let's see, the resistors weaken the current by burning of some as heat. Yeah, that's how I understand it, at least. That's what the little guidebook goes into as well. A really interesting just thing that I read the other day is that, how can I even say it? I don't know, let me get to it in a second, but kind of interesting point on that. So why don't we care about heat? Can it not overheat the components eventually? I'd imagine at some point, at least just for this little first Arduino project, it's not necessarily important that what it does with the energy, more so that it just reduces it so that our LED doesn't burn out. I would imagine that it does become pretty important. In fact, I know with how light bulbs work, you have so this is something that I learned about from this tutorial series on YouTube called Paul's Arduino tutorial. I don't know. It's this old electrical engineer, and he has his own Arduino tutorial series where he goes on about a little bit deeper into the electrical theory behind everything. But he talks about how light bulbs work, a traditional light bulb, where you have a wire that's all coiled up with the glass encasing and all that. But he says that what you do is that you send current through the light bulb. And so what ultimately happens is that the wire acts as a resistor. And you just really crank up the energy to where the wire gets so hot that it just starts glowing. It starts visibly glowing red. And then you get it hotter and hotter and hotter, and it starts visibly glowing white. So the wire itself is actually the light isn't really the main product of a light bulb. It's actually heat. That's why light bulbs can get pretty hot. The light is it's just more of a byproduct of heating up the wire. LEDs are a lot more efficient in terms of light production as opposed to a traditional light bulb. But yeah, I mean, so moral of the story is that it can get pretty hot if you keep pumping more and more current into it. So it really does become a factor at some point. But for these little simple circuits, it's not really going to be a factor what happens with your heat. Yeah, I've always just found that interesting. I don't know. Because it seems like this, I mean, the sequence of things can matter at some point, at some times, but I don't know. Ultimately, it is one path, you are right. Resistors do not have polarity because most are simply carbon film resistors which conduct current in either direction the same. Okay, makes sense ultimately. Yeah. This stuff is so fascinating to me. I get a kick out of it. Okay, so we had our basic LED setup here. So what we're going to do now is give us a little bit of control with a switch. So let's see what's going on here. Again, I like to kind of just etch out what's going on. There's our pathway. So of course, we're always gonna start at higher potential energy. We're always gonna start at this power. We're always gonna ultimately go to ground, least potential energy. So it looks like we're riding this red wire. I'm gonna hit a resistor. The resistor again is ultimately for the LED that's gonna be coming up. We have this resistor that's gonna be connected to this switch here. So we have these two portions of the breadboard here from this A to E and this F to J. They are not connected whatsoever. They're actually completely separate from one another, these two sides. And that's actually taken advantage of with the switch here. Because what's going to happen is when your switch is not pressed down, there's going to be no connection made between the left-hand side of the breadboard and the right-hand side, at least along these paths here. But if we do press the switch down, then the circuit does get completed. And so the current should flow like normal. Ultimately, we get the power here, goes to the resistor. When we press the switch, then it goes through this row 10 here. It's going to ride down to this row 13 on this wire, go through the anode leg of the LED, out to the cathode, and then we ultimately are going to return to ground. Oh, it's a little bit tricky. You can see that it goes from this leg down to this negative vertical row, so it's going to ride up back to this black wire. So I have it set up a tiny bit differently, but it's essentially the same thing. Right now I have this resistor to the LED. I'm going to move this LED a little bit further down so we can get the switch going. I'm going to remove this wire because that's just not being used anymore since I moved the LED. So let me go ahead and get my switch here. Call the push button on here. So I'm going to have to rotate this so that I get this hooked up properly. But now we can see I have from the power, goes to my resistor, which hooks up to the switch here. When the switch is pressed, it'll now be on this row here. So I got to connect from here to here. We use the red to denote that we're kind of still going through power. And it helps to, use this red to show that we're at the cathode. In fact, let me just maybe move this down so it's a little bit more obvious. That is such a short little wire there. I want to make it a little bit more visually obvious what's going on. If I can grab that. Okay, we have that. Now let's put this to let's connect this guy to this here. So now we're on our this vertical strip of metal for ground, and then we'll eventually go back to ground overall. So now we run this. We got power. This is going through. Go to the resistor to the switch. The light's not on because we haven't pressed on our switch yet. Once we do that, we have our lit LED. Beautiful stuff. Okay, so very conceptually similar to what we were doing before. Okay, even more switch fun. So this starts talking about series and parallel circuits. It didn't really, at least from the projects going forward, they don't really touch on this too much. At least, I think I've gone up to like project 10 in the book. They haven't really touched too much on hooking things up in series versus in parallel, at least from everything that I've done. I don't want to go too heavily into that as of right now. But maybe we can talk a little bit about Ohm's law. They do have a nice little section on it. But Ohm's law is ultimately the thing that's going to determine oh, hold on, my phone's blown up. Sorry, give me 1 second. My friend just is wondering where I'm at. I'm at home doing an Arduino stream. They're kind of worried, but hey, I'm working a MLH gig right now. Okay, anywho, so I want to make sure people aren't worrying. But anyways, let's jump back into this. So we have voltage, current, resistance. So going into this, so voltage, current, resistance, beautiful forces of nature. What exactly are they? What exactly do they mean? They're not exactly the most intuitive thing. Everything that I've read online has kind of said the same thing. But they're just some fundamental forces that go on to explain like how you're balancing your numbers and the like in your circuit. So ultimately, a very big aspect of this that we just were face to face with was that LED. Like, why was that LED freaking out when we didn't have a resistor? Let's get to the bottom of it right now. So we can see that if we hook this up again, so we go from this 5 volts to here again, to here to here. the red. Blah, blah, blah. Oh, there we go. That'd be nice to get a little bit of advertisement in there at the same time. So, okay, why aren't you working? I just sent blah, blah, blah. Oh, because look at that. I got to flip it around. Okay, not do there we go. Okay, so why is this freaking out? Well, let's do the math on it. So we have 5 volts. How this works out, we have current, what is it? Voltage equals current times resistance. Our units for each, a volt, voltage is going to be volts. I don't think that's technically correct, but I think it basically is, if you really want to get pedantic about it. Current is going to be amperes, which is just A. Volts is V. And then resistance are ohms, which is that like Greek letter that we saw earlier. Resistor. We put this guy here. You can see we have ohms, this like almost arch-shaped Greek letter. Ohms, which is, I don't have that on my keyboard, so I'm not going to be able to put that there. But how it should go is A equals, what is this, like dimensional analysis? Let's use an O for ohms for now. Technically, it's that, whatever that's called, that Greek letter. So now, the current that we're generating, it's not going to be full on amperes. It's going to be in the range of milliamperes, which is like 1,000th of an ampere. But let's see what this LED says when we start running this thing. With our 5 volts, current through the LED is 483 milliamps. So we have 483 milliamps, which ends up being, I think they have the equation here. Let me see. Oops. Just want to make sure I'm doing this right. So we're supplying 5 volts, as it says. Resistor offers 220 ohms of resistance that we had set up before. Blah, blah, blah. In fact, yeah, because I don't know, because it's not that you have like 0 resistance or anything. I think it makes more sense to start it by having the resistor. Because I don't know how you would calculate the resistance without that. Because otherwise it would be, I don't know, it just doesn't make sense conceptually to me. But anyways, we can go through and we can run the math. We saw that we had a 220 ohm resistor before, as we had set up for the LED previously. We have 220 ohms. We have our 5 volts here that we're supplying, equals some amount of our current times the 200 ohms. And we should ultimately have, divide both sides by 200. That's a bit misleading. So we should have 5 over 200, which should be, so I should equal 100, which should be about 0.23 amps, which is equal to 23 milliamps used by the LED. Okay, so it looks like, so this is what we generate 23 milliamps when we use that 200 ohm resistor. So again, if we set up this circuit, why is my reuse? Oh, that's annoying. I think it lost my history. But we have this set up right now. Oh my goodness, I'm just losing everything here. Oh, it's pandemonium. Okay, so anywho, let's go ahead and put this in here. Put this to 220 ohms. Okay, so you saw the colors changed on the resistor. Resistors actually have like a color coding scheme that communicates like how many ohmage, I suppose you could say, a resistor is. This goes way back to like the 20th century, where I guess colors are just more immediately readable and universally communicative compared to like writing numbers as a practice. And now it's just kind of stuck around. But we run this. Why is that not working? Oh, because again, there we go. Wait, what? Okay. Maybe I'm blind. Maybe you guys can help me diagnose what's going on here. 200 maybe? This is the anode, right? That's weird. Okay, so help me diagnose this circuit. What's going on here? Why is this not working? So we have the power being supplied. Power rides up to the anode, goes through the leg, goes through the resistor. The resistor now is hooked up to the ground. It should be exploding right now. It shouldn't say that we have no power to it. By the resistor to get the current. So LED has a rated voltage threshold. You take the source voltage minus the LED voltage threshold and divide by the resistance to get the current. True, true, true. Yeah, that's what I was a bit confused on a second ago. Was I didn't know what the innate LED like minimum was, but it kind of just gives it to you in the book. It says that about this 23 milliamps is the max that you can use with the LEDs that are provided. So that's why we use that 220 ohm resistor, is because it gets us to that safe range of 23 milliamps. So anywho, yeah, I don't know why this circuit isn't working. It's kind of funny. Maybe move this away a little bit. But I mean, anyways, we kind of had our main points with the circuit anyways. Oh, is that leg? I think something crazy was going on with that leg. Now I'm curious. Let's jump into this again. There we go. Okay, so that's working now. Okay, so anywho, a little bit of Ohm's law there too. In terms of what voltage is, in terms of what resistance is, in terms of what current is, that gets a little bit more difficult to explain, but it doesn't really cover it within the Arduino template or within the Arduino guidebook either. A bit of an explanation on it, but it's kind of not as intuitive to grasp. But from what I've looked into, current is the amount of electrons moving past like a certain point of the wire that you're measuring per second per unit of time. It technically measures something called coulombs, which is like, I think it's 6.2 times 10 to the 26th electrons. It measures like the coulombs per second that travel through at a particular point in the wire. I think you just arbitrarily choose whatever that point is. So current is the amount of electrons. Resistance is like a pseudo frictional force. Like as the electrons are going through the wire, they're like bouncing all around. Some are going backwards, some are hitting things, and some get accelerated a little bit. Some hit things and they decelerate a little bit. But there's all that chaos going on, all that pandemonium. But you can measure the overall. You measure like the overall movement of the electrons over time. You measure like the overall average forward movement. So that's what your current is. The resistance is like a pseudo frictional force that kind of slows the electrons down. Since the electrons are like hitting into things, I think that's what ultimately produces the heat that is associated with resistance, is like the electrons hitting all sorts of atomic, physical nucleus apparatus. I don't know what you want to call it, but so current's pretty straightforward. It's like the amount of electrons. Resistance is some kind of like impeding of the electrons' movement forward, slowing. I don't know if you'd say it slows them down, but if you lower the resistance, you lower the current naturally. Well, actually, hold on. Is that true? No, that's not true, I don't think. Anyways, sorry, my brain's not working. Anyways, that's some good little theory there. Then voltage, I can't explain to you. That one is a little bit too above me at the moment, but I've heard it described as like it's an electrostatic potential and sort of like an electron difference of electron pressure. I don't know. It's pretty interesting stuff when you really get into it. But there's some homework for you all. Learn more about current, resistance, voltage. So hopefully you can explain it to me in detail, because apparently it takes people quite a long time to really get a grasp on these concepts intuitively. But anywho, look at that. We learned about the electrical properties of voltage, current, resistance while building a circuit on a breadboard. With some components like LEDs, resistors, and switches, you created the simplest interactive system. A user presses the button, the lights turn on. There we go. Just like when we walk into a room, flip that light switch. Beautiful stuff. These fundamentals of working with electronics will be referenced and expanded upon in the coming projects. Okay, so now we're going on to our second project, Spaceship Interface. So I hope you all enjoy outer space. We're about to go on a very interstellar ride in just a second here. So this actually starts to use, we're going to use a little bit of coding with this as well. Hold on, made nice one. Okay, on this side. So okay, so anywho, we'll go on to see how we can use a bit of programming with the Arduino now, so that we can have more sophisticated controls. So we're essentially going to set up a little program to where the lights, a certain combination of lights are going to be set up in one context, and we can then change to another setup of how the lights are being illuminated in another context, all through code. Looks like it's going to be created via this button press. So when the button's unpressed, the lights are going to be set up in a certain configuration. Once we press the button, then the lights are going to be set up in a different configuration. So let's go ahead and build our, well, before we even build our circuit, let's get a sense of what's going on here. So essentially what's going to happen, again, if you sit down with a little book here and you give an explanation, and it kind of just explains what's going to go on, but I'll give the quick and dirty version of this. Again, you're always going to have your voltage being sent throughout your components and the like, and everything eventually goes back to ground. We're actually going to have a few different power sources here. We have the main voltage, like pin here. That's ultimately going to send current through this switch here. Talk about why that is for a second, or in a second. But you can see that these LEDs, we have these yellow wires here that are set up to connect to the anodes of these three LEDs. Why? Remember that the anode is going to accept the, how should I say that? We're going to be sending electrical energy through the anode. So this pin 3, 4, 5, again, not even having to read any of the instructions or the like, we can just tell that these are going to be supplying electrical energy to each of the anodes. So this is where the LEDs are going to get their power to light up, is from these pins on the Arduino. What these pins are, we'll talk about in just a second. But now you can see that each of these LEDs also has a resistor set up so that they won't burn out. And then all these resistors we can see are connected to ground. So there's a little circuit made there with the LEDs. Okay, so we can see how the LEDs are set up. This main 5 volt is not connected to the LEDs though. So why is that? Well, let's see where this goes. So we trace from here to the red strip, through here to the switch, and then on the other end of the switch, before we connect to ground, we have this green wire. Okay, so we're not connecting to ground, we're connecting to this 2-pin here. So it makes us wonder, okay, so why is that? Let's delve into a little bit more detail of what's going to go on. So what's happening is that we're supplying power, we're supplying voltage to this red wire, hits the switch, or it doesn't hit the switch. What this green wire is doing is it's detecting the amount of voltage running through. If the voltage is low, then it's going to tell the computer, like your computer that the Arduino is hooked up to, it's going to say, if the voltage is low, run this sequence of the lights to where the lights are going to flash in a particular way. So this green wire is actually connecting to sort of the brain of the computer. That's what these digital pins are here. Like this label from 2, 3, 4, 5, 6, 7. These are called your digital pins. They're going to interface with the computer essentially. So here, since we have a green wire, this green wire is Arduino's way of just kind of color coding that we're going to have data or some sort of electrical information inputted into the Arduino. These yellow wires is their way of color coding, hey, we're going to take information from the computer and like output electrical energy based off of that information that's on the computer, whatever our code is telling us to do. So that's just their personal way of color coding, like the functioning of these pins. This green one is set to take information from the outside. These yellow wires are to put electrical energy out to affect things in the real world. So anywho, what I want to say from there. So when this button is not pressed, there's low voltage. The light's going to flash in some way. When this button is pressed, now this green wire is going to detect that there's high voltage. And the high voltage is going to tell the buttons you're going to send a different sort of lighting pattern to the buttons through the programming, which is going to be connected, which is going to be delivered through these yellow wires. And then this resistor here is, from what I understand, this is like a really strong resistor. This is like a 10K ohm resistor. I think it's only to prevent, how can I explain this? I'm trying to think of how to articulate it. So how this green wire is working is it's either sensing very low voltage or very high voltage. We want there to, if this button is not pressed, we want there to be very low voltage. From what I understand, this very strong resistor is being used so that there's like a really, really low voltage level being registered. Because if you have a resistor this strong, pretty sure it should like bring the voltage level super down. Someone correct me on that if I'm wrong. But it's to essentially like have this binary operation of like low versus high to be very, very drastic, so there isn't like any false positives or like any meandering in the middle that could cause some like false positives. Let's see. Voltage is the force that moves the electrons like pressure. So here's the interesting thing. Apparently voltage is not a force that moves the electrons. That's called the Coulombic force. Voltage is considered an electrostatic potential. Yeah, I didn't know that at first either. It gets like, you can get explanations of voltage can get kind of pedantic with the terminology and the like, but Yeah, apparently voltage it's the Coulombic force, which is the force that moves the electrons. Voltage is the electrostatic potential between two portions of the wire. The implications of that and what that really means on a deep level, I don't really know. Not exactly there yet, but should give something fun to delve into at least. Something that I'm still trying to grasp myself. Okay, so anyways, let's see what's going on. Let's go ahead and build this circuit. So let's see where we're going to start. So let's go ahead and build up our basic thing here. In fact, we can do, I don't want to break this up conceptually because, there's kind of two different things going on in a way. One is just the supplying of the current to all these LEDs, which we'll do with the code. So we can just light up these LEDs in and of themselves, and that will work fine. That's one thing. But then we want to be able to alternate patterns of lighting depending on how we push the button. So like the button being pressed and alternating the different patterns of illumination is kind of a separate thing in and of itself. So let's go ahead and set up the individual LEDs. I think maybe that's a natural starting point. So we're using right now our digital pins. So these digital pins, I hope this isn't too ugly, though this has it set up. But I'll show you guys. So again, we're using yellow here to showcase that we're like going from the computer, sending electrical energy out into an LED. So we can flip this. Let's do a resistor. Oh, why is that not working? Oh, okay, never mind. So we have power getting set up to our anode, as we know. We'll set up a little resistor so that this thing doesn't burn out on us. We want it to be 220 ohms because, as we learned, that sets us up to the 23 milliamps, which is a good level for the LED to have current flow through it. Oh, actually, I gotta move this up a little bit. There we go. Okay, so now, so we still have to connect this to ground. So we have to connect that with a black wire. I could probably manage the cables a little bit better, but that's okay. Oops. Oh, I want to move you. Why are you not letting me move you? Oof, that's a little ugly. Hold on. Why don't I want to do this? That's like visually easy to see what's going on. Okay, so we can go like here maybe. Okay, so we have the power coming from here, going through the LED, resistor, run this. You're gonna notice that it doesn't turn on. Why? Well, because the digital pin doesn't know what it needs to do. We have to set up the digital pin to either be input or output. Right now, it's not set as anything. So I don't know if it defaults to something, but it's not doing anything. So this is where the code comes in. The digital input can either input or output. We want to tell it to output. So that involves writing some code. Starts us off with the blocks. This is a lot like Scratch if you guys have ever worked with that before. Actually, I'm going to go to the text thing here. So this is some starter code it gives us. In the little booklet here, it actually shows you what code to write, and it explains like how it works. But we're going to do some, kind of walk us through this. So in every Arduino program, there's two I guess you could say, yeah, two overall functions that you need. There's the setup and there's the loop. The setup is the code that runs once, only runs once, and it runs as soon as, it's like the first thing that runs in the program, and it only runs once. And then you have, so that's your setup code, and we'll see exactly what that's used for. And then we have our loop code, which is going to be run continuously as the program goes through. So you have your setup, it's run first, it's only run once, and then we have the code in our loop, which is ran after the setup and which goes through continually. So we need to actually fill this up a little bit. So for our setup, we want to use this function called pin mode, which is just built into the Arduino's language, I suppose you could say. So pin mode takes two arguments. It takes the pin in question. So we want to take pin 3 and we want to set it to output. Again, a pin can either output electrical energy or it can intake information for the computer to interpret. But here we're going to do output because we want to output some energy to this so that we can light it up. So with that, I think we have to set it digital write. Okay, so now this is set to output. It's not automatically going to start sending energy or start sending a current, a voltage, however you want to say it. What we need to do now is say, okay, so now you're in output. Now I want you to actually apply or supply current to this. So you have high or low. They're your only two options. You either can supply current or you can't supply current. That's why it's a digital pin. It's binary. You do or you don't. It's either on or it's off. So it's high. I think the supply is 5 volts overall. Maybe I'm wrong, but I'd imagine so. So it supplies some amount of voltage. So now in our code, we have pin 3 set to output, and we're having it's turned on to where it's actually supplying voltage. So now if we start it, it should work. There we go. Okay, so now it's working. So we essentially just set up 3 of these as shown here. We just have 3 instances of this. But I want to show you like what we can do with this. So we can go on to set a delay. This is in milliseconds. And I'll explain why we use a delay in just a second. But we have a delay there. We just make this flash essentially. We can say turn it on, wait like 250 milliseconds, turn it off, wait 250, and say turn it on, 250, and then we'll turn it off. This is bad spacing practice, but that's okay. Turn it off, and we'll have it wait for 500 milliseconds. So you can see we have like pretty full control over this thing. Why is this? My code has some errors. Oh, because I didn't put these here, semicolons. Okay, maybe it's not fast enough. Maybe it's not slow enough. 500, 500, 500. Let's go 10,000 or 1,000. See if that works. Okay, so there we go. So you can just start to see the sort of control that we have over this. So the value of the resistor is 220 ohms. So if I click on here, oops, right there, 220 ohms. That's right. Voltage is also relative potential between 2 points. Only can be defined as between 2 points. Yes, it's again something I still have to learn a lot about myself. All of that good stuff. Let's see. Yeah, happy to help. So the electrostatic potential in the wire reminds me of how the cell we have potential of ions that also have charges. How in the cell we have potential of ions that also have charges. The higher the potential, the easier it is to diffuse ion down the gradient. Probably the same concept with higher voltage. I would imagine so. There's this really good video on YouTube by this guy called Alpha Phoenix, to really delves into Ohm's law. To like he explains exactly what voltage is, exactly what current is, exactly what resistance is. Really good video. I've been taking notes on it. I've watched it a few times, and every time I watch it, like things like more and more clicks. So definitely delve into that if you find this interesting, because he goes into detail on all this stuff. I'm kind of just parroting everything I learned from that video, truth be told. It is really informative. Okay, so we can see how we can use code to have some fun with this, right? So all we got to do is set up 2 more LEDs exactly like this that work in exactly the same way. Instead, we just have to set them up on different pins. So let's get rid of this tomfoolery here. And get a parallel thing set up. Let me make sure I'm kind of following the demonstration in the book, just so that we can easily cross-reference what we're doing. You know, if something goes awry, we can kind of see what's going on. But you can see, like, I'm placing things at like slightly different areas. I'm not too concerned about being down to the letter of everything that they're hooking up, because it still works no matter what. You still want to be organized and the like, of course. Actually, hold on. I'm trying to change my LED color. We want 2 reds, the 1 green. And it's just the same story. Going to be supplying voltage. Should I say supplying voltage or supplying current, if anyone knows? I want to make sure I'm using the correct terminology here. Like the Arduino concepts and stuff I can make my way through, but my overall electrical theory is definitely lean to learn more about that. I'll be the first to admit it. And number 5. Okay. You can see we have all set up to the anodes. We have these yellow wires, which we're going to be supplying voltage with. And then we just need 220 ohm resistors on all of them. Let me move this back a little so that it's kind of clear where everything comes in and the like. So I want to move that back. Okay, so now we have pins 3, 4, and 5 all being used. And the exact same setup, right? So if I go into my code and I do the same thing, if I do pin 4, it should probably be like this. Okay, I don't know why the code is going crazy. Pin 4, pin 5, the numbers being right along here. Then we should have it to where pin 3, pin 4, pin 5, I can set those all to being high, and they will all light up, as we shall see. There we go, so they're all on. Okay, so here's where the interesting stuff happens. We can see that this is all working. We can flip the digital write states to being high, which is where they're turned on, or low. I actually didn't show that, so we'll have this middle one be low, and it's just not going to turn on, right? Because we're not supplying anything to it. Okay, so easy does it. So that's like the one component of this overall circuit, or this overall project. I'm not sure if I think these would be considered separate circuits. Again, I'm kind of really getting down into maybe semantics, you could say. But I guess the overall project here, right? This is like one aspect of it, is setting up these LEDs to be turned on. The other aspect is we're going to write a program to where if the switch is off, we're going to have a certain setup here of what's high, what's low, in terms of what's turned on, what's turned off. If the button's pressed, then there's going to be a different state of how these are illuminated. So let's go ahead and set up the button now. So the button will... Let's just go ahead and get the button. So we have the button here. Oh, it should be set up between these two, set it disconnected. Then we said we want, so from the button here, want to put this green wire to pin 2. So we don't use pins 0 or 1 for this because they have some sort of special function with how they interface the Arduino with the computer. That's why we start on pin 2 and then we go up from there. But this pin 2 is ultimately going to read how our voltage is going to be affected by whether the button is pushed down or not. So now we need a really strong resistor. Again, from what I understand, to prevent false positives and the detection of the voltage. So I think it's 10,000 we want. 10,000, wait, no, hold on. 10,000 kilo ohms, so we just want 10 there. Just going through. Does it not specify? It should. $120 ohm. There we go. Okay, so 10,000 kilo ohm. We want to put that right. Actually, probably want to move this forward a bit so this can connect to ground. Take that to ground. Okay, so now we actually have to supply voltage to the button, or at least set up a pathway for voltage to be supplied to the button when we press it. Because all this is set up, but we actually don't have a way to provide voltage until now when we set up these red wires. So going from here to here, a little bit messy, but that's okay. I want to show you guys that there's different ways of doing this. So I'm just setting up your circuit. In fact, let's go ahead and do this so that's not as messy as it has to be. Okay. So ultimately how this works, we supply voltage through this cable. It's going to hit the button. Now, if the button's not pressed, the circuit is not going to be complete here. So this is going to read, this green wire is going to read that there's no voltage coming through. So it's going to tell the computer to output a certain, pattern of setting off the lights. If the button is pressed, voltage is going to run through. This green wire is going to read voltage, and the computer is going to tell the computer is going to then output a different set of illuminations. So now we just need the code for that. In fact, let me just copy it from my, I think I already have it made out. I could copy it from the page, but that's a bit much. We're already we're almost an hour and a half in already. That's kind of crazy. Oh, sorry, hold on, let me share my screen again. Sorry, just checking the chat for, I gotta bounce back and forth between my windows. So why do some pins have, right, so there's that little squiggly line, there's the tilde. So what that means is that you can do pulse width modulation, which is there's kind of a key to it right here. It's not exactly obvious at first though. That little tilde means that pulse width modulation is possible. And so what the book will go on to tell you is that pulse width modulation is what you can use to vary the brightness of the LED. So again, these pins, you can only have high or low. You can only have on or off. So either your LED is at, it's either bright or it's off, normally. However, what you can do is that you can vary the speed of how you turn the LED on and off. So you can turn it off, like on, off, on, off, on, off, on, off, super, super fast, to the point where in reality it's turning on and off at like a super high speed. But perceptually, how we perceive it visually is that when it's, what would it be? I think it's when it's super fast. So when it's just plain on, the LED is at its max brightness. When you're turning it on and off, when it's super fast, it's basically just the same thing as being at its max brightness. But as you let it be off for longer and longer and longer, as relative to how long that it's on for each little flash, you start to perceive the LED as being dimmer and dimmer and dimmer. So you can modulate the rate of how long it's on versus off. And from there, you can affect the perceived brightness of the LED, if that makes sense how I explained it. It's kind of interesting. So what book is this? This is the Arduino project book. Yep, there we go, Circuit Student. As he said, book that comes with the official Arduino kit. So why do we not need the big red wire for the LEDs to light up? Yep, exactly here. Each of those pins acts like a source as long as the ground is present. So we have these yellow pins here. These can either input or output. So these are actually outputting voltage, just like how this, how we've seen with the big red wire here. These pins are outputting voltage in the same way. It's just that we can turn it on and off with code, is the difference. So pin 2 will be an input source though, not, yep, exactly. If your speed off is higher than speed on, then it dims. Yeah, that makes sense. Exactly, so that's exactly it. Yeah, happy to help with that. So I don't know why only some of them are pulse width modulation. Seems like a little bit arbitrary which ones are, which ones aren't. But that's the explanation for that. So yeah, you go on to use that in a different project. There, you can use it with the LEDs. I believe you also use it with when you use a servo motor, from what I can remember. But anywho, okay, so we talked about the setup and the loop. Oh yeah, that's right, I copied the code. So I'm just going to paste this in and we're going to walk through it together. Okay, so we have the setup function and the loop function. Again, the setup is the code that runs right out the gate. It only runs once. The loop is the code that runs after the setup, and it keeps getting run over and over and over again. So in our setup, we initialized our pins, or we at least declared what we want, how we want our pins to function. So as we said, 3, 4, and 5 pins, 3, 4, and 5. We want those to be output, right? Because we want to supply voltage with them. Pin 2, we want it to be input because we want it to read voltage from the switch. If we press on the switch down, we want there to be voltage detected. If the switch is going to be up, the circuit's not closed, so we want to be able to read that there's no voltage present. Okay, so now within our loop, so that's our setup, right? Just ran once. Now within our loop, we want switch state, digital read 0. I don't know why they didn't do it up here. Interesting. Essentially, it's just we're just reading this digital pin, this number 2. So basically, it's saying if the value, so this digital read, we're capturing the value at a current point in time. We're capturing whatever value at the current point in time is being sent to this pin 2 from whatever voltage is ultimately being detected. So we read the value of the voltage. We save it to this variable switch state. If switch state, which is just the, if there's voltage or not voltage, if it's low, if there is no voltage, then we want to light up the LEDs in this fashion, where the green will be turned on, these reds will not be. That's if there is no voltage, if the button is not pressed. So if the button is not pressed, only turn on the green LED, reds can be shut off. If the button is pressed, then what it ultimately does is it shuts off the green, and it has the two reds flash between the two. So we can see that we use a bit of a delay here as well. The reason why we use a delay is because, how can I say it? If there's no delay, then the lights are going to flash just like super uber fast. Because this is running at the speed of the code, right? And code can run pretty dang fast. So we want to make sure that we put in a delay so that we have the intended perceptual effect to where these are slowed down. In fact, we can just run this as we see it. So as we said, when the button is not going to be pressed, only the green light's going to be on. When the button is held, green light turns off and the two red lights flash between each other. Okay, so button is not being pressed. Now if we press it, look at that. Let go of the button, green light turns on again. So there we go. Now we used some programming and the concept of these digital pins to both output and input to affect how things work. Pretty fun stuff at the end of the day. And again, this just goes through, kind of explains the code. And then here it explains that resistor color code as I was talking about before. The colors on the resistors actually, it's a system that communicates the ohm value of the resistor. Okay, let's see what it says. In this project, you created your first Arduino program to control the behavior of some LEDs based on a switch. You've used variables, an if-else statement, and functions to read the state of an input and control outputs. I guess I could explain the code a little bit too. Are you all familiar with like the concept of if-else statements and variables and all that? I mean, this book, if you go on, again, there's this booklet here, which you can only get if you purchase the Arduino, but that Tinkercad source, that Tinkercad website, it has these same tutorials, so it actually gives an explanation of all these concepts as well. There's a lot of coding resources online that explain things such as variables and if-else statements, loops, stuff like that. If anyone has any questions on it, I'd be happy to explain. Otherwise, I think we can just focus more on the electrical side of things. Love-o-meter. Turn the Arduino into a love machine. Using an analog input, you're going to register just how hot you really are. Okay, well, I think for all of us, it would just burn out. This is a good group we've got going here. So, I don't know if this project would even work for us because there'd be no variation. But let's go ahead and give it a shot anyways. So let's go ahead and can I just completely delete this so that I don't have to deal with all of that? No. Hold on, can I like shift and then, oh, okay, cool. That works. Okay, so breadboard, small, rotate this. Okay, so we're gonna be using a temperature sensor, which has a few pins. Let's just jump right into this and I'll give you guys the rundown on it. Okay, so we have a temperature sensor. This temperature sensor, we're going to set it up to where it's going to read a range of values that are going to ultimately light up these LEDs. Or if it's not very hot at all, there'll be no lightage. If it's at max value, all these should be lit up. And then we, of course, have the continuum in between where we'll have different lights lit up to the different values in between. So, anywho, let's see what's going on. So, pretty similar thing to the last project, right? We had these LEDs, which are just set up as very basic. We supply voltage to the LEDs here with a digital pin. Resistor so that the LED doesn't blow up, or at least it doesn't blow out, I should say. And we just set that up thrice. Then we use I would say that. I don't know where that came from. But anywho, now we're going to use this temperature sensor to affect how these LEDs are lit up using actual temperature, real world. Or in our case, simulation of temperature. It's probably just going to give us a slider that we can move back and forth. But let's go ahead and set up these LEDs. So same story as before. Let's get some LEDs pulled up. Let's see what's going on. Okay. LEDs. Go ahead and rotate this, mirror it, so we have the anode set up how we want. The anode doesn't always have to be on this side. It's just following the book, make it a little bit easier. So we want 3 of these guys, and then 1 more. And then we're just going to set it up as we have been. So we have digital pin 2 on this farthest, 3 on this middle, 4 on this topmost. Change these to yellow because, again, that's just the way that the Arduino book prefers to color code. Yellow means that you are setting it as output. So we're going to be providing voltage with these. And then each one needs a resistor so that we don't burn them out. Want 220 ohms. Okay, so now we set this up to go to ground. Everything is hunky-dory. So again, if we were to run this at this current state, nothing's going to happen because we don't have the pins set. There's no voltage being sent. But that's okay. We don't have to go through all that again. We get the idea now. So now what we want to do is set up this temperature sensor. Temperature sensor, this guy here. Swing him around. Put him here, I suppose. We can put it at this farthest end. Okay, so this has 3 prongs. We have to connect it to power. We have to, on this power prong, naturally the power leg. Connect it to ground with the ground leg. And then this middle leg is what we're going to use to read the temperature value. And then, as you can see, we have this green wire here. This is just, we're going to send it right to this AO, this A0. So this is an analog in. So we're going to be reading an analog input. That means that, so digital means that you only have on and off. There's only 2 states. Analog means that there's like a continuum of value that you can either input or output. So right now, we want to be able to read, we want to input, we want to read a continuum of possible value. So that's why we're using this A0 instead of, say, like another digital pin. Want to be able to sense that whole continuum of value that we can read from the temperature. So that's that. We're going to be sending that to here for the Arduino to read, but we also have to provide power. We have to provide voltage, that is. And we also have to connect this to ground. And the circuit as a whole, jeez Louise, has to be sent to ground. Okay, a little bit of a mishmash here. See if I can. Oh, I don't like how it's crossing. Let me just steal how they do it, honestly. I think that's a bit better. Oh, I didn't even have it set it up right. Well, I guess I did. You can just send it directly to here. You can send like the voltage from like this 5V directly to here so it gets to the power. But then the wire management just gets a little bit... Wires start crossing and everything, so I'm actually going to put it up here. I'm going to put it from here to here. And then same thing for the ground. I'm actually going to put it up here now, just for wire management, so that we can like more easily see visually what's going on. Then let's move this down a little bit, maybe. And then we can connect this to ground. And then there we go. Okay, so that works out pretty well, actually. So we have to supply the voltage to this. Goes up here, goes down to this red, goes to the power here. Then this goes to then exits to the grounds. This black, then it goes all the way up here, and then to the ground. Okay. And then we have this green pin to read temperature sensor. So now we have a circuit there completed. Okay, so we have all that fun stuff in place. So we have all the electronic components and everything placed to the breadboard, but we need the code now. So our cable is actually different besides color. At least these basic cables, they are not going to be different. They don't function differently at all. So you could use these, like the ones packaged in the Arduino kit. You could use like the different colored cables however you want. You know, you can mix them up as much as you want. The color coding is just so that you can understand like how all these cables are functioning, like what the overall meaning of the cables are, why they're being used, or how they're being used. But that's a good question though. And then same thing for these, like on the breadboard too. See how like we have this like plus strip, we have this minus strip. These are actually just thin strips of metal. There's nothing special about them. This plus and minus, they're just printed on the breadboard so that it's just a guideline to follow, so that you can like more easily like organize the way that you're managing the flow of the current as you're putting your circuit together. So like I could connect the power to anywhere on here, you know, so long as I like keep one of these rows strictly to the power. That makes sense. So there's again, yeah, there's that higher layer of meaning that you can technically disregard, but it's very helpful if you do use it as intended. So we have this in place. Now we just need the code. So I'm going to snag that code and I'll walk through it with you guys. This is our level meter. So let's see what's going on. So there's some constants, variables we're defining. This is actually going to print stuff the console, it looks like. I don't want to walk through this together. Let me see. I don't know why I'm yawning so much. The sun is, it's actually kind of dark in here now. It's evening. I think it's tricking my brain. Anywho, let's just run the code. I want to see where it's printing to. Okay, so it's actually working at least. See, we can see that these LEDs are lighting up. I should be able to click on this and okay, so you can, it's kind of small, but you can see that there's like the value in Celsius as we go up. So as we go all the way down, negative 40 Celsius, right? Nothing's on. As we go higher and higher and higher, we start to see the LEDs turn on. What is the range for this thing? Okay. I don't know if it's as fine. I mean, this is a pretty obnoxious temperature scale. Going all the way from 125 Celsius all the way down to negative 40. That's not very practical room temperatures, but anyways, it does work overall. How this goes through baseline temp. Serial begin, open a serial port. So it's basically just setting our pins up, setting these guys up to be outputs, and there's going to be no voltage running through at first. That's our pin mode. We just have like a little a for loop going from pins 2 to 4, saying that they're all going to be output pins, and they're all going to be there's going to be no current supplied at first. Then there's just like stuff printed to console. Like it's gonna print we're gonna calculate the temperature and what is it? The voltage reading is gonna print to the user. The degrees in Celsius that's being read, because you have to convert the voltage value that's being how can I say this? So this temperature dongle here, however you want to call it, the temperature sensor, is going to sense a temperature, but it's not going to feed temperature to the Arduino, right? There's going to be a correlation of temperature to voltage. So it's going to read a temperature and it's going to output like some amount of voltage. That voltage is then going to be read on this A0 pin, and whatever that voltage is representative of the temperature that the sensor initially sensed. So that's essentially just all what this code is doing here. It's basically saying, hey, we're reading this voltage, or we're reading this temperature, we're reading this, and we're outputting this voltage. Let me show you what that voltage is. Let me show you what the temperature is that caused that voltage. Then we have this if-else statements here. If-else statements is essentially just setting the range of when we want, what does it say? So baseline temperature is a variable that we set. So it's going to be 20 degrees Celsius. So if temperature is below 20 degrees Celsius, all of these LEDs should not be on. The temperature is between 22 and 26 degrees Celsius. We want to turn 2 of them on. And if it's higher than 26 Celsius, then have all of them be on. Okay, so let's see. So we said that if it's below 20 Celsius, they should all turn off. Okay, if it's between 22 and 26 Celsius, only 2 of them should be on. So we see that. Okay, we move it up a little bit more, like 23, it should still only be 2. Now if we go beyond 26 Celsius, like we're at 36 right now, or beyond, then it should be all 3 turned on. So there we go, it's working. And then too, like in the real world, I mean, here we have the software slider, but remember, this is all like, the Arduino kit is a real physical thing. So you could actually, hold up some heat source to this, or something cold, and affect how the temperature sensor, what it's valued is that it's reading, and you'll actually have these change physically. It's cool stuff. Okay, so that's that project in a nutshell. Again, there's all sorts of like little theory and the like too, and it's introducing new coding concepts and different theory and the like as well. But I want to give us a taste of some different aspects of this, so I don't want to stay on one project for too long. But again, if you either go through this booklet or you go through the Tinkercad tutorials, which is like a one-to-one to this booklet, it'll teach you all sorts of nice concepts to know. Okay, so it says, what's our summary here? Expanding the types of input you can read, you've used analog read in the serial monitor to track changes inside your Arduino. Like I was saying, before we've only used digital pins. So we can either turn something on or turn something off, or read if something is on or read if something is off, right? It's just a binary state. But with this analog pin, we can read a whole range of values, which is what we did here. And use a function called analog read to read that, to read from these analog pins, whatever that particular value is within that continuum that's possible. We got 13 minutes left or so. Let's see if we can do one more project. Whoa, okay, so this is a little bit more involved. Nothing too crazy, but doesn't look like anything we've done before. At least visually, it looks like there's a bit more going on, but nothing too crazy. Any questions, any comments as right now on anything that we've been going over tonight? Just curious. Okay, let's see if we can knock this out, people. So again, let's try to break this down. So essentially what's going to happen, this is a color mixing lamp. So essentially, we have three LEDs here. Oh no, not LEDs. They read, they're like light sensors. What do they call them? Photoresistors. Okay, so photoresistors change the resistance depending on the amount of light that hits them, also known as photocells or light-dependent resistors. Okay, so they're going to deliver a certain amount of resistance depending on how much light falls upon them. So these are photoresistors. So we have three photoresistors. And what you do with them ultimately is you put colored gels on them. So on one, we'd put a red colored gel, a blue colored gel, and a green colored gel, I believe it is. The reason why is because you put a gel on something, you're basically putting a filter on it. So how can I articulate this? Essentially what we're going to do, we're going to read the amount of red light, the amount of blue light, and the amount of green light that's coming in from a particular light source overall. And depending on the lights, depending on the reading of the light that we get, we're ultimately going to light up this LED here with that. So essentially what I mean is, let's say we had our red, green, blue photoresistor here. If we shine a light only on the blue photoresistor, then this main LED is going to light up blue. If we shine a light only on the red photoresistor, this LED is going to light up red. If we shine on a mixture of these, then we'll have the overall result shine on here. So if we shine a light on the red and the blue, then this LED should light up purple, for example. And then it just goes from there. So how this actually works is you have the same photoresistor 3 times, but they package these little gels with them. It's kind of cool. But anywho, let's get this set up. So clear our breadboard here. In fact, I think I'll just do this again. Oh, that's not what I wanted. Get another breadboard. Breadboard small. Just check the chat here. Okay, so let's go ahead and set up our photoresistors here. Again, kind of the cool thing about this is that, not cool thing, but just a good way to approach this is try to understand the different parts of what's going on here. So we have the photoresistors here. You want to set them up so that they're ultimately sending data to the computer through the Arduino. So we can see that we have these green cables. So ultimately, they're going to be detecting this light and sending it to the computer. So let's go ahead and set that up first, just kind of easily to grasp. It's just kind of easy to grasp conceptually. I think it's a good starting point. So photoresistor looks kind of different than they look in the book, but that's okay. Wow, how would you even... I think we have to set this up differently than how they have in the book, because these are really... They have a wide stretch. Whereas that's just not happening here. We could probably do this to emulate it. In fact, yeah, let's do that. Okay, so essentially, we set up 3 of these photoresistors. Whoa. That was on 26, it looks like, so we can do that. Oh. Okay, I don't like that. So this is not how you'd set it up in the real world, but I don't know why they have the components set up so differently, but we'll just do it like this to kind of mimic what's going on in the book. So we'll have, so with this one, we're going to ultimately have it go to an analog. Again, you want to use the analog pin because analog pins can detect a continuum of values, right? It's not just on and off. There's a whole spectrum of values that it can detect. So here we do. So here we have it. So it's going to detect the light, then send it off to the computer. So we need this 3 times, and one more time, and then 2. Oh, that's annoying. Hold on. Now this is not a polarized component, so we should be able to just flip it like that. Can I do that? Yeah, that works. Again, a little bit goofy. I think this should work how we have it, but just the software visualizations. I want to make sure this is understandable. Okay, so now we just do the same thing. We're hooking all these up to analog inputs. Okay, so that's all well and dandy, but we actually have to supply voltage to these now. So how are we going to do that? Because the actual components and on the actual Arduino like span this big thing here, this big gap. They actually have you send the voltage to the other side here, and then ultimately come down. So these are connected, it looks like, in parallel then. I don't know why the reason is for that exactly, but that's just how it works. As unsatisfying of an answer as it is right now, but definitely encourage you to jump into it, kind of understand why this is set up the way that it is. Okay, so we can see how this goes, right? From this voltage 5, this 5-volt pin, go across, come down here, and then it goes to all these in parallel. And then we need these resistors here. Again, I think this is that, is this the 10K? Let me see. Oops, resistor. No. Yeah, I think it is. Okay. Again, I think this is for, I don't know if this would be for like the false positive we talked about before. Interesting. Oh, this is a little bit, I have to move this up. There we go. Oh, no. There we go. Just so that's not as visually busy, the resistor and the wire. So we have that in place. We can see if we have enough time to set this up. Now we just need to... Oh, this is just a resistor hog. That's kind of crazy. I wonder why this is set up the way that it is. I never really explored that. I did do this project before, but I never thought to think about why this is all needed. But, well, I guess there's 3 different LEDs inside of it, right? There's a red, a green, and a blue, I would imagine. And so you're just turning them on at different... That's interesting. Notice too how we have these all set up at different pulse width pins as well. All these pins you can do pulse width modulation with. And we talked about before how pulse width modulation is how you can create the effect of brightness versus dimness in an LED. So, okay, that's actually interesting, and I never thought about that before. So we're reading analog inputs from here, right? We're reading like a value of, we're reading like along a continuum of values for each of these, for the red, the green, the blue. That's what we're reading. Now we're translating that to a continuum of values here in our LED ultimately, but we're using digital pins, so we can't directly do a a dynamic value. That has to be on and off, but we can give that sense of dynamism by using pulse width modulation to create the brightness or the dimness. I never actually really sat down and thought about that with this project. That's actually pretty interesting. But there we go. So we're learning, folks. I'm learning too. That's always a good situation. Okay, well, I don't think I'll go on to complete this. We only have a couple minutes left. If anyone has any questions or the like, or just any comments or anything of the sort, I'd love to know. And kind of just open the last couple minutes to discussion on what we learned today. So is there any questions, any comments of the sort, anything that you learned today that you didn't know previously, or just anything else that's on your mind? Any general questions? Let's see. So the sense voltage, it looks like they use a voltage divider circuit in the book, hence the 10K resistors in series with photoresistors. The sense point is in between the resistors. Okay. Sense voltage was they use a voltage divider circuit in the books. The sense voltage series. Okay, I'd have to sit down and take that in, honestly. That just kind of shows my inexperience with the electrical stuff. I love learning about it, though. I will certainly keep this in mind when I come to understand the circuit better. I appreciate you for giving that insight. Just joined. What was the Arduino going to be used for? We were just learning about the basics of the Arduino. We built some basic circuits, like we looked at how to turn on LED, or how to light up LEDs, and oops, wrong one. We looked at how to. A lot of the projects were just LEDs at first. I'll give you a really quick tour. So this first one was just having voltage go through to turn on an LED. Then we hooked up a switch that you can turn the LED by pushing the switch on and off. We didn't do these ones, but it's just like series versus parallel. And then we use code to be able to create flashing patterns of LEDs, depending on whether the switch was pressed or not, but just a lot of stuff like that. But it is the hour, so I'm going to bring things to a close here. Yeah, super cool. Yeah, the Arduino it's a lot of fun. I love it. It's some of my favorite thing as of late. But with that, we are at the end here. So thank you, folks, for joining tonight. Lots of more fun events coming up for Data Week. Go ahead and stick around and see what we have planned next. Thank you all again for joining me. And with that, have a great rest of your day and a good rest of your Data Week here at Global Hack Week.